Here we're going to look at divisions involving indices. In the last video, I talked about multiplication involving indices, and we came up with this general rule: a to the power of m times a to the power of n is equal to a to the power of m plus n. This one's going to be very similar. It's important to note that in the last one, the bases were the same, and in this one as well, the bases are the same. So we've got a base of a, and then our powers can be different. They could also be the same though. So we're going to look at two examples first, and then we'll come up with a general rule. So the first example is 2 to the power of 5 divided by 2 to the power of 3. So as I've done up here, we can rewrite that as a fraction because fractions and divisions are related like that. So I'm actually going to write it like this because it is much more intuitive to see it this way. And what I'm going to do is I'm going to expand that out. So I'm multiplying 2 by itself 5 times. And by itself 3 times on the denominator. And then we can see that if we try to simplify this, this denominator is a common factor with the numerator. It has a common factor. So when I have a common factor in the numerator and the denominator, I can actually cancel them out. So all I'm left with is 2 times 2, or in index form, that's 2 squared. Here's a second example. This one's going to use a pronumeral. So I might just use a. It's a nice that let us write down over and over again. So a to the power of 6 divided by a to the power of 2. So again, I can rewrite that in fractional form. And I can expand that out, multiplying a by itself 6 times on the numerator and 2 times on the denominator. Just like we did before, I can take that common factor and I can divide it out. So I'm left with here a times by itself 4 times, so a to the power of 4. So what we can notice is if we're looking for a general rule, in this first one, the powers were 5 and 3, and in the solution, the power was 2. So that's 5 minus 3 gives 2. And in this second one, we've got powers of 6 and 2, and in our solution, we have a power of 4, and 6 minus 2 is equal to 4. So that's going to be our general rule. We're going to have a to the power of m divided by a to the power of n. So the same base with different powers. We're going to keep the base and we are going to subtract the powers. It is really important that when we are doing divisions, we make sure we've got it in the correct order. That's because subtracting numbers does actually make a difference when you subtract them in different orders. If I was to do this backwards, I would have got 2 minus 6, and I would have got a to the power of negative 4, which would have been a different answer because negative indices do mean something different. They're, in fact, the exact opposite. So using this rule that we've just come up with, we're going to do a couple of examples. So here we go. I'm just going to rewrite the rule at the top here. There we go. And we'll start with 2 to the power of 9 divided by 2 to the power of 5. So using the rule, we'll keep the same base and we will subtract the powers. So we're left with 2 to the power of 9 minus 5, which is 4. For this next one, we've got 3 to the power of 14 divided by 3 to the power of 5. And you can really see here why it's much easier to use this shortcut than to expand it out and simplify it. So we're going to do 14 minus 5, and we'll get 3 to the power of 9. So each of these, I'm writing the answer in index form. Or in other words, I'm simplifying the expression. We'll do a couple more where we're doing that. So here's a couple with pronumerals now. Y divided by 10 divided by y squared y to the power of 10 divided by y squared is going to be y to the power of 10 minus 2, which is 8. This one has a coefficient at the front of the pronumeral. So we've got 12x to the power of 5 divided by 3x squared. So just like when we divide algebraic expressions, we're going to divide the 12 with the 3 to get 4, and then we'll subtract the powers of our x. So 5 minus 2 gives 3. So the number at the front isn't the base, so it can be divided, whereas the x stay the same because it's the base of the power that we're dividing. This one's got a numerical base, but it's actually going to have algebraic powers. So the exponents here are 12a and 4a. So we're going to keep the base the same as 3, and we're going to subtract the powers. Now 12a minus 4a can be simplified a bit further because they are like terms. So 12a minus 4a gives a final answer of 3 to the power of 8a. And we'll do one more of these type. M to the power of 6, n to the power of 5, divided by m squared n. In this case, we have two different pronumerals that we need to divide. So we'll start with the m's. We'll do m, keep the same base, to the power of 6 minus 2 gives 4. And then n to the power of 5 minus 1, because n, just a plain n, is like n to the power of 1. So that's going to subtract to make 4 as well. M to the power of 4, n to the power of 4. So all of those were finding a solution in index form. We're simplifying the expressions. I'm going to do two more short examples where we're going to do what we call evaluating. Evaluating means finding the value or finding the basic numeral. Is how it's sometimes expressed. So these ones above were in index form. Basic numeral means find the answer, find a final value. So here's two short examples on that. First one is 3 to the power of 9 divided by 3 to the power of 4. So we can see 3 to the power of 9 is quite hard to figure out. 3 to the power of 4 even is as well. So we'll just simplify that. 9 minus 4 gives us 5. Now that's 3 multiplied by itself 5 times. 3 times 3 times 3 times 3 times 3. So I'm actually going to use a calculator for this one. Just in the interest of time, I'll just clear my calculator. And we'll do 3 to the power of 5, which is 243. And one last question. We've got 8 to the power of 9 divided by 8 to the power of 7. Again, going to be quite difficult to solve this if we didn't have a calculator, to solve this without simplifying it. But if we simplify it down to 8 squared, 9 minus 7 is 2, then we can just solve this one without a calculator. 8 8s are 64.